This is lesson 2, calculate perimeter and area. The learning goal for this one is to look at the basics of what perimeter is and what area is. And the success criteria is to calculate the perimeter and area of rectangles and squares, and the volume and capacity of prisms using familiar metric units. This is a relatively simple skill with only 4 different examples I'm going to show you. And hopefully these skills have been already learnt within primary school. This first question here, which measurement shows the perimeter of this rectangle? Now perimeter just means the outside lengths of a enclosed shape, generally enclosed shape. You can find the perimeter of open shapes, but generally the shapes are closed. Now here we see that this is a rectangle, and the rectangle has 4 sides, and 2 of these sides have been provided to you. What we need to do is just fill out what the other sides are. And this is simple because this here will be 7 centimeters, that's it's the same here. And this side here will be 3 centimeters, that's it's the same side. And all we need to do is just calculate 7 plus 7 plus 3 plus 3. And this will give you how many centimeters entail for the outside or the perimeter of the shape. And this is 20 centimeters. Nice and simple. If it's a closed shape and it has the outsides, you will just add the outside shapes up. This also happens for squares as well. Now we'll get in a question where it is asking for the area of this square. Now area, the formula for the area for a square or any type of square or rectangular shape is length times width, where L is your length and W is your width. Now this is a special circumstance because here we're talking about a square, and a square, all of the sides are exactly the same. So an area in this case can just be length times length. It's the same type of formula, there's a multiplication involved. So in this case our area is just equal to 3 times 3. And 3 times 3 is 9 centimeters. Now we don't just leave our answer like this. We've got to make sure that there's a little 2 on the top. This is called a square unit. Now what this just means is that we're talking about 2 dimensions. In the previous example, when we were looking for the perimeter, even though we've got the length where there's 2 dimensions, the actual length all up, if you were to line this 20 centimeters in a line like that, from 0 to 20, it's all one line. So it's 1 dimension. So technically there should be a 1 here, but by default, we just don't write that 1 there. We just leave it blank. But when we're talking about 2 dimensions, we put that little 2 here because then the person who's reading this can say, we're talking about an area, we're seeing length times width. And this 9 just means if we were to split up 3 centimeters into the actual 3 centimeters and go all the way down, and then again 3 centimeters, there's 3 centimeters all the way across, what we end up having are 9 squares in the middle, and that's where that 9 comes from. So in this case here, our answer is 9 squared centimeters. Now, a lot of the questions are just within that format until you get a question that looks like this. The perimeter of this basketball court is 70 meters. What is the unknown side lengths? So now it gives you the perimeter amount as 70 meters. So our perimeter, we'll just call P, is 70 meters. So I know that if I was standing here and I were to walk all the way around, I would cover 70 meters of this perimeter. And what we do know is that one of the sides is 25 centimeters. So that means this side here is also 25 centimeters. But we don't know what this side is here. And as a consequence of that, we don't know what this side is here. So we need to use a little bit of logic to try to figure this out. All right, so how much of this perimeter do we know? If we know that this is 25 and this is 25, 25 plus 25 is equal to 50 meters. So if we were to just walk this track here, or this side of the track and this side of the track, we've covered 50 meters. Meaning there's a difference of 20 meters left. There are 20 meters left. So this 20 meters has to contribute to both this side and this side. And because there are two sides, we'll just split them off. We'll do, well, obviously this side has to have 10 meters and this side has to have 10 meters. So then when we add this up, this is 25 plus 10 plus 25 plus 10, which is 50 plus 60 plus 70, which is the initial amount that we began with. So one of these sides is 10 meters. Be careful and don't choose the 20 meters because we have 20 meters left. It's asking for one of these sides, not both of these sides. So we've got to be careful and just put the answer of 10 meters. The last question here has to do with an area and when an area has been given to us. In this case here, the area of the floor plan is 120 squared meters. And we're looking for this unknown length. So we know that the area is equal to length times width. Now, this side length we don't know. The side length we don't know, which is this. But this width here we know as 12. So our area, 120, is equal to 12. Or actually, I'll just do length times 12. So some number multiplied by 12 will give us 120. Now there are different ways of working this out. You can obviously know that this answer has to be 10. This is the only number that can be multiplied by 12 to give you 120. But if you ever get stuck in this case, we can always just grab 120 and divide it by 12 to see what our answer is. This gives us 10. So the amount of meters here has to be 10. Now, because this is multiple choice, you could have tried all four of these numbers to see which one gives you 120. That also works in this case as well, until you get to a question where it requires you to actually fill it in. If you need to fill it in, this is where you would use this process here. And that's all there is to it. Very nice and simple skill. Go ahead and attempt this skill, and I'll see you in the next video. Bye-bye.